everyone. Today we're going to be looking at projectile motion. What is that? In this specific case, we're just going to be focusing on one dimension. What does that mean? It means we're only going to be focusing on objects that goes up and comes down in a straight line, not like mine though. Oh dear, there he goes. Not that kind of projectile motion though. Alright, so we're going to be focusing on just something that goes up and come down. Of course, it can be thrown from an airplane or an air balloon, or it could be, of course, I'm standing on top of a building and whatever the case may be. Or we're even going to do ones where there's two at the same time in the air. Now, what is projectile motion then defined as? It's defined as when an object is moving either upwards or down in free fall, which means the only force that is working on it is gravitational force. So if I would be jumping out of a plane and let's say we completely ignore air resistance, that would be I'm in free fall. Free fall means the only force working on me is the force of gravity pulling me down. Alright, so you would remember, guys, from grade 10 already. Let me give you the 4 formulas that we're going to be using. And of course you're going to get them, but you still need to know how to use them. So it looks like this. Where this is my final velocity, initial velocity or speed, that is my acceleration, and when we work with projectiles, it's always going to be 9.8 meters per second squared downwards. Alright? So whenever I let something drop, it's going to fall downwards to the center of the earth. And we've got our time. So that's our first formula. The second one looks like this. Alright, normally we would write delta x, but in this case where we work with vertical motion, we're going to write delta y. Okay? Then we've got a different one that says delta y equals and because of this, you're going to be using a lot that formula that you learned in maths where you have a free term. So you're going to just add it into your formula that you do have on your computers or your and then work out that the value of t would be. Of course, time is always positive, so you always choose a positive value. And then we've got the final one that looks like this. But I want to add an extra one. And that is something that you have done also already in grade 10. That when an object moves with a constant velocity, that means there's no acceleration, that you're going to be working with a value where you have an acceleration at 0, or we could just as well use this formula that says my speed equals my displacement divided by time. So that would be the formula that I would use if my speed is constant. So it's a constant speed. Right, so then we've got our formulas. Now let's have a look at a typical kind of a projectile motion. So let's say you are standing on a building. You're throwing a ball into the air. So the ball goes upwards, alright, reaches a point where it's going to turn and fall back all the way to earth. Alright, let's have a look. I'm not going to do a problem, I just want to point out a few pointers to you guys. Alright, what is important to know? So we say we start here and he throws it up into the air with the initial velocity. In that case, let's just use a value of 10 meters per second. Now tell me, what happens with that ball if I throw it up into the air? Is it just going to continue moving? No, of course not. it's going to reach a point where it reaches a velocity or a speed of 0. So it's going to go slower, 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 stops for a split second, and then start to accelerate, speed increase again towards the Earth. So at that highest point, we know that its final velocity up there equals 0 meters per second. But just be careful, because they want to always kind of like give you a question where you immediately answer 0 meters per second. But they very often ask the question, what is the exact acceleration at that exact spot? And then the children, of course, the readers write, what do they write? The learners, they write, it's 0. No, it's not 0. At that highest point, the speed is 0. But the acceleration is still 9.8 meters per second squared downwards. Otherwise, it would have stayed there. Alright, so remember that. Acceleration downwards always. Doesn't matter if I go like this, 20 times, turning in the air and then falling down to Earth, all the time. 9.8 is the acceleration that's working on me as an object. Right, so let's continue. We could, of course, also then make the assumption that because there's no air resistance, that when it falls down, at that same point it passes me, it would again have exactly 10 meters per second as a speed, but going downwards. Why do I say that? Because it will go slower, 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 and at the same rate it would go again faster, 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 faster. So it would have exactly the same speed when it gets to the same point, passing me going downwards. But let's say it hits the ground at a final velocity of which is unknown at this stage. Something else that I can also know is that the time for it to go up equals the time for that ball to come to that same point to there, down. Of course, going past me, then falling all the way to the Earth or to ground, 0 point would be much more. Alright, so let's have a look at what we've got here. Now the important thing that you now have to do is you have to choose a direction. So you could either choose up as your positive or down as your positive. Now I'm going to choose, for this case, let's work with upwards as my positive direction. Now let me just point out quickly a few places where you might just get it wrong. Now you have to consider what is vectors and what is a scalar. The only one where you don't have to worry about direction is time. Time doesn't have a direction, but all the rest of them you do need to focus. When you have your formula and you write your values in, think very carefully about the plus and the minus because of the direction that you chose as positive. Let me show you an example. So let's say I just start with this formula here. I'm not even going to say what the question is, but I'm not going to use that formula, and this is the scenario. But I selected up as my positive. Then that means that my initial velocity, because it is being thrown upwards, will be positive. So yes, I have an initial there as positive. Time, no problem. Half, no problem. What is the acceleration on that ball? Even though it goes upwards, we know acceleration is always down 9.8 meters per second squared. But I chose up as positive, so you can see my 9.8 is going in the opposite direction, so I need a minus in front of my 9.8 value there. Alright, but that's not the only thing. What about my displacement, delta y? Guys, now you have to focus. What is displacement again? Displacement means from wherever you started straight towards your finishing point. So not up and down, that would be your distance. No, displacement, beginning straight towards the end. So you can see, hopefully, that goes, my arrow goes down, but I chose up as positive. That means my delta y also has to get a minus in front. Right? You can remember that? So just very careful when you work with your formulas. And guys, yes, there's no instant solution to which one you have to use. You just have to kind of like practice. I don't have time. So if I don't have time, maybe I can use that formula. Or I don't have my final velocity. Oh, if I don't have my final velocity, maybe I can use this one. Or I don't have my delta y, then I can use that one. So you start with the formula, start putting in what you have in your question, and if you see now I don't get anywhere with this one, it's fine. Start with another one. But do start to put in, and guys, don't cross something out, eh? Even if you start with a different formula, leave this one, leave it be. Maybe you have to remark a paper at the end of matric, and that might just give you that 1 point that you need to go from 79% to 80%. Great! So that would be my first important thing, is direction. When it comes to projectile motion, direction. Now let's have a look at the second important thing. Right. The second most important thing that you're going to have to be thinking about when doing projectile motion is, for example, they have something like, let's say it is an air balloon, or it could even be a moving SpaceX going up, and it already reached a certain speed where it has a constant speed of, let's say, so feet constant of 10 meters per second. So let's say that is a SpaceX, being projected up away from the Earth, but it came to a point where all the forces working on it is equal, and it is now traveling at a constant speed. Now let's say something gets dropped off from this SpaceX airship. Let's say it's an extra petrol tank that is empty. And let's say that petrol tank is then dropped and falls directly down towards Earth. Alright? So there it is. So we've got two things moving. We've got the SpaceX going up, and we've got whatever they dropped, the petrol tank, going down. Now, what does the petrol tank actually do? Let's think about the motion of that. Is it just falling straight down? No. Why? Because it's got already an initial velocity of going up, because it was part of SpaceX. Alright? So as it is part of my spaceship, it's also moving at a speed of 10 meters per second upwards. So for it to be able to turn and come back to Earth, that 10 meters per second initial velocity is going to come down to 9, 8, to a point where it reaches 0, and only then it can change direction and fall down to Earth. So never forget that part of the motion. So because it was part, let's say that just like this, it's part of this going up, it gets loose and it starts falling down, but because it's traveling up, it first also has to go up, reach a point of 0 speed, because only then you can change direction. So you can't change direction in mid-air. You always have to first come to a standstill, and then I can change direction. Alright, so we've got two movements here, one going up and one doing that. And of course, it all happens in the same time. So if you've got two things simultaneously, then just keep in the back of your mind already that it might be that they ask you, at what height is my SpaceX module or whatever, what height would it reach in the same time that it takes for the petrol tank to reach Earth. So immediately you have a time for this one going up equals the time for this one coming down. But just remember, if I would now choose as my direction of movement downwards as positive, that I do have an initial velocity then upwards as -10. And then we've got pretty much the same scenario that we had as if I was standing on a building and I would project an object or a ball into the air before it starts to fall down. Alright, so that is the second thing that you need to remember when you do projectile motion. Alright, so if you keep all these things in mind, especially with the two things working simultaneously, keep also in mind, guys, that what they very often do is they don't give you enough information. So it might be that you would have to have one of the formulas and just create a formula, use the same formula for the SpaceX and for the ball, but differently. Might be that you have then two different ones, that is unknowns, and that you have to continue by then just putting those two unknowns and say they equal each other, and then you continue to work out. So I'm going to do an example like that with you just in a moment. So, but the best thing with projectile motion is, guys, you have to go out there, get old papers, work these problems out. And it doesn't come easy. It doesn't come easy. There's no secret to this. There's no easy way out. You have to sit there and struggle, get it right. Take a different one, struggle with it, get it right. But do sit and work it out, because it's not going to happen just on its own. But believe in yourself, you can do this.